Hello, and welcome to a little video about Target 5A where I'm going to introduce systems to you. Today we're not going to be solving them, we're just going to be writing them. Alright, number 1. Oh, whoops, my bad. Control Z. Alright, so the Morton soccer team sold 500 tickets. Each adult ticket cost $12 and each student ticket cost $7. They made a total of $4,495. Let's write a system. Okay. So first, I moved it again, Control Z. First, I have two unknown pieces of information, and that is how many adults came to the game, how many students came to the game. So I'm going to define my variables. X, I'm going to write adults, and Y are going to be students. Now the first sentence, the Morton soccer team sold 500 tickets, tells us about the total, tickets. We sold an amount of adult tickets and some sort of amount of student tickets in order to sell a total of 500. The other piece of information that I have in this work problem is about the money that we made. So the second equation is going to be total, and I'm just going to write dollars for money. All right, so we have amount of tickets, and then we have the money made from tickets. Let's write an equation for the total money. Each adult ticket costs $12. Each student ticket costs $7. So 12x plus 7y gives us a total of $4,495. Number 2, Ms. Gumin bought her first hour donuts and hot chocolate. Each donut cost 75 cents, and each cup of hot chocolate cost $1.40. Her total before tax came to $43.20. She bought a total of 42 items. Let's write a system. Now, there are two unknown amounts here, or unknown items. The first thing I don't know is how many donuts, because I know how much they cost, I just don't know how many she got. She being me, but in imaginary land. And I also don't know how many cups of hot chocolate my imaginary self bought. Now, could you do D for donuts and H for hot chocolate? Absolutely. But you would need to write D equals donuts, H equals hot chocolate. One way or another, we need to define our variables. All right, so what are the two equations we can write? Well, the second sentence tells us about the total amount of money Gumin spent. The third sentence, I can count, I swear, is about the total items. Let's write those equations. First, let's talk about money. Each donut was 75 cents, so 0.75x. Each hot chocolate was $1.40, so 140y equals $43.20. Total items. Well, she bought 42 items, and those consisted of some amount of donuts and some amount of hot chocolate. X plus y equals 42. You decide to go on a very romantic date to Taco Bell. You buy 3 tacos and 1 burrito. You spend $8.25. Your date buys 4 tacos and 3 burritos for $16. Let's write a system of equations. First, let's think, what don't we know? Well, I don't know how many I know how many tacos and burritos I got. I don't know how much each of them cost. So, I'm going to do X for tacos. You could do T for tacos, you'd still need to write it. And I'm going to do Y for burritos. Now, unlike the first two problems, we don't have total money and total items, we have two separate people. We've got you, and we've got the date. All right, let's talk about how much money you spent. Well, you spent money on 3 tacos and 1 burrito for $8.25. Now, do we need to write that 1 next to the Y? No, we don't. But you wouldn't be wrong if you did. Let's talk about our date. Our date bought 4 tacos and 3 burritos for $16. So you, 3x plus 1y equals 825. Your date, 4x plus 3y equals 16. Number 4. You and your brother go to Foot Locker and buy some sneakers. By the way, you're best friends with your brother for this to work. Okay. You buy 3 pairs of shoes and 2 pairs of socks. You spend $78. This isn't a world of imagination, okay? We'll pretend that that's possible. Your brother wants to be like you, your besties. He buys 2 pairs of the same shoes and 4 pairs of the same socks. He spends $60. Let's write an equation. Now, once again, we don't have 2 different total items and total money. We have 2 different people, and they buy similar things. So my equations are going to be about us and our brother, but our unknowns are the costs of shoes and socks. So X is shoes, Y is socks. Those are the 2 items which we don't know the prices of. This is a perfect example of why I like using X and Y, and that's because, well, what are we going to do with shoes and socks? They're both S's. You'd have to come up with something else, and I don't like it. But it really doesn't matter. As long as you're using 2 different letters to represent 2 different things, you can use literally any letter you feel like. You just have to define it for me. First, I buy 3 pairs of shoes and 2 pairs of socks for $78. Your brother, 2 pairs of those same shoes and 4 pairs of socks for $60. I'll be right back. I don't feel like starting this video over, but I have a student at the door, so hang tight. We got 2 problems left. One more minute, I swear, guys. I swear. Okay, maybe that was less than a minute, but I'm back. Yay! Thank you for hanging out with the silence. All right, number 5. Marcus opens a new bank account. He deposits $25 that he won at a robotics competition. He also plans on depositing $10 a week that he earns from tutoring. Philip decides he wants to save money as well. He already has $40 saved from mowing lawns over the summer. He plans to also save $10 a week from allowance. Lucky duck gets an allowance. Let's write a system. Okay, so this time we don't have really 2 items that are unknown. Like we had shoes, socks, donuts, hot chocolate. But we do have 2 different people, so I know that that's what we're going to be writing equations for. One's going to be for Marcus, and the other's going to be for Phil. Okay, now, what don't we know? Now, the first thing I see that we don't know is weeks. I don't know how many weeks these guys are putting money in. So I'm going to write that X equals weeks. Now let's think about what could Y equal? What other thing don't we know? The other thing that we don't know is how much money is in the bank account. So total money. Because each guy is going to have money in his bank account. We just don't know how much. All right. So when I think about bank accounts, I think about starting with the total. Or if I'm thinking about money, I always like to start with how much money do I have? Or how much money am I going to spend? So I'm going to start this equation with Y equals. Okay, now Marcus. Marcus put in $25 straight into his bank account. So 25 goes in. And so plus $10 a week. Now Phil, his total money in the bank account starts with $40 that he saved. And he also puts in $10 a week. So a little different, because we had 1 unknown item, and then we had an unknown total, instead of 2 unknown items. Okay, number 6. Rachel needs to print some of her digital photos and is choosing between Lightning Fast Photo and Snappy Shots. Lightning Fast Photo charges a base of $5.20 per photo. That means you have to pay $5 no matter what, and then each photo you upload and print, you gotta pay 20 cents. Snappy Shots, on the other hand, charges $7 just to sign up, and then 10 cents per picture. So let's write a system. This is gonna help Rachel figure out where she's going to, give her business. Because I would go with what costs less money in the end. Now, what do I not know? I don't know how many photos Rachel wants to print. That's what we're talking about. We're talking about printing photos. That's the only item. So what could y be? What could the other variable be? Similarly to the deposit problem in number 5, we're thinking about the total money she's going to spend. Now, is it the total money in the bank? No, but it's the total money we're going to spend, which is still something that's important to look at. Or I guess in this situation, we're thinking about spending rather than saving like we did in number 5. That's what I meant to say. Yes. Okay, so we have our unknowns, where we defined our variables. We have 2 companies. We have Lightning Fast Photo, and we have Snappy Shots. Let's write one for Lightning Fast. The total money Rachel will spend at Lightning Fast Photo is going to be y equals $5 plus 20 cents, 0.20 per photo, so X. Same thing for Snappy Shots. The total money Rachel would spend, y, equals the $7 they require and plus 10 cents per photo, 0.10 X. And that is our short little lesson for Target 5A, Day 1. I hope this was helpful. If you have any questions, please feel free to ask me or any of your teachers. Have a wonderful rest of your day. Bye!